the Space Development Group from George Mason University's Systems Engineering Senior Design Project 2012. I'm Robert.
I'm Daniel.
I'm Scott. I'm On.
In this video, we will be giving a brief overview of our project, creating a positive feedback investment cycle to achieve a lunar habitat, return on investment calculator for capability stepping stones. In October of 1957, Russia sent the first satellite into Earth orbit, the Sputnik 1. This event triggered the formation of NASA in 1958. 11 years later, the United States was the first nation to put human life on the moon. The projects NASA has created since its inception have generated many new technologies, such as the CAT and MRI machines, and the foundation for the personal computer. While federal spending on space programs begins to decrease, private industry funding is on the rise. Many new companies, such as SpaceX, Virgin Galactic, and Bigelow Aerospace, are now becoming the driving force behind developing new space programs and technologies. Reigniting the space programs will lead to new technologies and capabilities, as well as generating economic growth by providing new jobs and markets. The difficulty of developing space is very high due to space debris and high launch costs. Space debris creates a large risk to orbiting bodies from collision. There are currently an estimated 1,900 tons of debris in low Earth orbit. How can we achieve a developed space while spending efficiently and generating a return on investment for all stakeholders? By developing a single string design that builds on stepping stones, we can develop space in a more cost-effective way than the current industry plan. Collaboration and cross-investment from industry will allow technologies to be built faster and cheaper than they currently are. The lowest projected launch cost is currently $1,000 per pound by SpaceX. This, however, can only be achieved using the FALCON Heavy rocket with a launch frequency of 4 times annually. The need for higher frequency is what will help keep the cost low until technology can step in and decrease launch costs. Currently, there is not enough space activity happening to stimulate an economically sound space market. The lack of activity leads to minimal investment, which in turn leads to a lower launch frequency and then leads to less interest in space development. Less interest will continue to feed into the lack of activity, creating a disinvestment cycle. Unless this cycle is broken, the space market will not be feasible.
This leads us into our next statement, which is there is a need to break the disinvestment cycle by focusing on reducing the launch costs and insurance premium that will lead to a profitable development of space. And our problem statement is evaluate the cost and revenue to find synergy and stepping stone capability, investment to break the disinvestment cycle.
Due to the complexity of the development of a lunar habitat, we have broken this goal down into a set of sequential capability stepping stones. This single string design represents a logical progression necessary to achieving a permanent lunar presence. So here we have our capability stepping stones. They are as follows. The first stepping stone is high altitude tourism. This stepping stone is modeled after Virgin Galactic, and the capability achieved through the stepping stone is commercial tourism. The second stepping stone builds on the first stepping stone by providing debris collection. Here we look at the effect of removing debris on insurance rates. The third stepping stone is low Earth orbit LEO habitats, modeled after Bigelow Aerospace inflatable habitats. After removing debris in LEO, habitats can be placed in LEO to be used as research facilities in microgravity. An infrastructure to maintain these habitats is developed through this process. Stepping stone is a LEO hub and moon base. Utilizing the modularity of the habitats from the previous stepping stone, we can create a LEO hub that serves as a space station, as well as a temporary moon base comprised of more of these habitats. The capabilities gained through the stepping stone are the continued exposure of civilian consumers to space, development of space-exclusive ships traveling between the LEO hub and moon base, and temporary habitation of the moon. Finally, we reach our destination, a permanent lunar habitat. The capabilities obtained here are lunar life sustainability, which is made possible through lunar mining and manufacturing. To recap, Stepping Stone 1 serves as a catalyst for interest and investment in space. Debris collection reverses the declining trends of conditions in LEO. Low Earth habitats Stepping Stone 3 provides an environment for government and private sector to conduct research and increases the frequency of traffic to these habitats to sustain them, therefore decreasing launch costs through economies of scale. Stepping Stone 4, Leo Hub and Moonbase, serves as the extension of tourism and sustainability into space, space-exclusive ships, and a temporary presence on the moon. Finally, permanent lunar habitation provides us with a lunar mining and manufacturing and serves as the basis of delving further into space. As for our design, there is an independent model for each stepping stone. These models were created in Spec Innovation's Nimbus SE, a functional database and modeling tool. These models were combined together to create an ROI calculator that serves as a decision support tool.
As Scott said, each one of these stepping stones are constructed, and we're able to produce investment and revenue curves for each. You can see right here we actually have our investment and revenue curves for stepping stone 1, where we break even in about 5 years, and for right below that we have our investment and revenue curve for stepping stone 3, where we break even in a little over 10 years. The other thing we're able to get is the reduction in cost from insurance as we proceed through these stepping stones, and that is our top graph. Right below that we have a graph showing the effects of launch cost reductions by continuing with the stepping stones. The next thing we did is look at the effects of not doing debris collection stepping stone 2 before we start doing Leo habitat stepping stone 3. And you can see here in this graph, we actually have the cost and revenue curves for that scenario. The red graph is what would happen if we failed to do debris collection before we did Leo habitats. And you can see here in a little over 12 years, we actually have an increase of cost of roughly about $1 billion. We also then looked at the effect of reducing launch costs on the system. So as you can see here in this graph, we have the orange line, which shows what would happen if we had a perfect launch cost, something along the $1 per pound. The blue line above that was our expected launch cost based on what our model was able to produce, which comes out to roughly about $250 per pound. The red line on top is finally the launch cost for $1,000 per pound based on the SpaceX values. You can see the green line goes up, and at each point it does hit the break-even point earlier and earlier depending on our cost. So for $1 per pound, we actually break even in about 5 years. Expected is a little over 8, and finally, if we maintained it at $1,000 per pound, we actually break even in about 10 years. The final trade-off analysis was looking at the required investment by not doing mining and manufacturing on stepping stone 5, permanent lunar habitats. The green curve is the default investment with mining and manufacturing, and the red curve is without mining and manufacturing. This increase in cost is driven by the fact that everything is required to be launched from Earth, including habitats and also life support. From this analysis, we developed a capability rank list. This list identifies our recommended investment order. The initial investment needs to go into debris collection, followed by a space-exclusive ship that does not require the dangers of leaving Earth's atmosphere. Third, an investment in habitats for both Leo and also Lunar is recommended. Thank you for your time. We'd like to thank our sponsor, Dr. Dan of Spec Innovations, for giving us such an interesting and unique project. Also thanks to Dr. Sherry, our faculty advisor. Once again, my name is Daniel.
I'm Scott.
I'm On.
And I'm Robert.
Bye-bye.
There's a force operating on the educational pipeline that will stimulate the formation of scientists, engineers, mathematicians, and technologists. You birth these people into society. They're the ones that make tomorrow come.